precipitation as a way of making salts and ionic equations. That's what I'm hoping that this lesson will be about. Following on from what acids, bases and salts lesson I gave last time, you are in the section required to make various salts, and there's a flow diagram which I've shown you before, this one. I know it might seem complicated, don't worry, I've got a simplified version of this later which I want you to learn, but I just want to show you that today we're going to go across this the top region. Is the salt we're going to make, is it soluble or insoluble? And this method is used to make soluble salts. This method is used to make insoluble salts. That's salts that do not dissolve. So you need to know your solubility table. You need to know what chemicals dissolve and which ones don't. The ones that don't dissolve, the insoluble salts, this method, insoluble salts, is done by mixing together two soluble salts in solution. As a mixture, they will make the insoluble salt we want. As a precipitate, it will be formed and we'll filter and separate it, and filter and separate off the salt. It's out of the three methods, it is the simplest method of making salts. And typically, when on an exam they ask you about it, there are 5 marks. 5 marks, at the most, about 5 marks, and they relate to the method and what we do, and I want you to learn the method, etc. So what is the method? Well, precipitate. Understand the word precipitate means a solid made in a reaction. So there I've got a diagram of 2 test tubes with 2 solutions in, and the 2 solutions make the salt. There is in red. They're going to make the salt, and the extra other chemicals are going to stay in the solution that's around the red dots I've got there representing the salt. So that's the salt there. This is the solution. These are 2 solutions. So really it's crucial as to what solution should you start with there, and what solution should you start with there. So the 2 solutions, what should you start with? You should start with solutions that have the right ions within them to make the salt that you're trying to make. So you start with the name. What's the name of the salt? And from that, you know the solutions. Now the solutions, solution 1 and solution 2, we're going to mix them together. So solution 1 has to have one of the ions in. Solution 2 has to have the other ion in. So this solution 1, I want you to pick a nitrate. This one is X nitrate. Now I've used the letter X as the first part of the name of the salt. So say you want to make lead chloride, start with lead nitrate. Say you want to make barium sulfate, start with barium nitrate. Whatever it is you're trying to make, start with that nitrate. Now the good thing of this method of picking a nitrate is that all nitrates dissolve. So you can guarantee whatever you start with, dissolve it in water, you can guarantee it will be a solution. And we need to do the same thing with solution 2, except solution 2 is going to give us the second part of the name. Here, sodium and Y, sodium Y, Y representing the second part of the name. Say we wanted barium sulfate, then sodium sulfate is what solution 2 would be, sodium sulfate. Barium nitrate. One of the ions, X, is in one solution, the other ion in the salt Y is in the second solution. Now, again, the good thing about picking sodium anything is that all the sodium chemicals that begin with the name sodium, we call them sodium salts. All the sodium salts dissolve in water. So you can guarantee that sodium anything will dissolve in water and you'll be able to get a solution. So they are your two solutions. Now, my pupils find that the hardest bit. Which two chemicals do you pick? Well, it's not hard. The first part of the name there, X. Second part of the name there, Y. And when you mix the two together, then you're going to get the salt, which is XY. You're going to get that as a precipitate. It's going to form solid because this is a way of making insoluble salts. That salt will be a precipitate because the salt is insoluble salt, and therefore solid will remain, and it'll either float around if its density is low, and it'll sink if its density is more than water. But you can guarantee the insoluble salt will be made, and it will be made inside the mixture, and all the other chemicals, the nitrate ions and the sodium ions, will be in that solution above. In the solution will be called sodium nitrate solution, because nitrate, sodium, sodium. These are the other ions in the solutions, the ions that are not going to react, the ions that are just in the water, they're in the solutions before, and they'll end up in the solution later above the solid precipitate, which is what we want, and we'll filter that to get the salt that we want. So that's the idea behind it. The idea is simple. Pick two solutions, mix them together, filter, wash the salt, and dry it. So let's have a look at a completed method. I want you to write a method like this if asked to do so. There, 5 points. So to make two solutions, point one's probably the trickiest bit, is you've got to mix two solutions using water. Choose, what do we choose? Choose a nitrate, choose a sodium salt, mix those together. Why do we pick a nitrate? Because nitrates all dissolve or soluble. Why do we pick sodium something solution as a second of our two solutions? It's because all sodium salts are soluble. They dissolve in water. So having got the right two chemicals as solutions, and I'll demonstrate some, you can have a look. We mix them together. Number two, mix these solutions together, and the insoluble salt, that's the salt that won't dissolve. And remember, this method can only make salts that do not dissolve. The insoluble salt that doesn't dissolve, will form as a precipitate with the sodium nitrate as the solution that's all around it. So that's in the water bit, the solution above. Filter to separate the precipitate. That precipitate will be the salt that you want, and that salt that you want will be on the filter paper, so we call it the residue on the filter paper. Then you wash the crystals by pouring a little water over them, and you dry the solid crystals in a desiccator. I'll show you a desiccator in a minute. There, that's a desiccator. Watch. Ta-da! Desiccator. Desiccators are posh biscuit tins because they've got this white solid, calcium chloride, that absorbs moisture. It takes the moisture out of this top section. The top section is therefore kept really, really dry. If I have something wet, like say that box of matches is wet, put it there, put the lid on. If I leave that, leave it a day, then that box of matches will be perfectly dry. If you put a box of biscuits in there, the biscuits will remain crispy and dry. They won't have that kind of dampness that as biscuits absorb water moisture. So to me, that's the best biscuit tin in the world. It's called, in science, that piece of apparatus called a desiccator, and I want my pupils, I want them to dry the crystals using a desiccator. Some of my pupils want to dry the crystals in an oven. Some chemicals will decompose in an oven. Ovens can get too hot and the crystals will break down, and that's not what we want. When we want to dry something, we want to safely dry it without messing it up. Desiccator. Or they do allow, on exam papers, they allow you to say, get some filter paper, and imagine that is your crystals, and they do allow you to say, get your filter paper, dab the crystals. If you dab the crystals with filter paper, it does dry them a bit. The filter paper will kind of, a bit like a sponge, it will absorb the water droplets that are on the crystals. But look, in science, you'd use a desiccator. You wouldn't be dabbing with filter paper. You might dab with filter paper if you don't have a desiccator. If you don't have desiccators, dab with a filter paper. That's why the exam boards allow it. Not all schools have got desiccators, etc. Okay, so let me move on to some examples. How would we make barium sulfate? Now, let me see if I can get the examples switched around here. Barium sulfate. So, maybe I can hold it like this. The two solutions, barium nitrate and ideally here I'd want sodium sulfate, which I couldn't find. Oh, barium nitrate this way around. Let me do that again. Barium nitrate there. Barium nitrate where my finger is. Barium nitrate. Now I've got the bottle the right way around. Magnesium sulfate, because I couldn't find sodium sulfate. But, you know, if you had sodium sulfate, exactly the same thing would happen. These ions, sodium ions, magnesium ions, it doesn't matter so long as it dissolves. And magnesium sulfate does dissolve. So this experiment will work. And I'm going to show you. Like this. Don't know, maybe I'm going to have to do this kind of thing. They are my two solutions, and I'm going to mix them in a beaker. So beaker, two solutions. There. Now that white precipitates because you cannot see through it. You cannot see through it because it's formed. That white precipitate will be barium sulfate. Now if I get funnel, get some filter paper, fold it in half and half again, put that in there and filter. hope you can see that. Move all these away. Now I'm speeding this along a bit. I'm rushing it just to make the video a bit shorter. But essentially the salt is formed in there and sits on top of the filter paper as a residue. And if I don't rush it, then the solution coming through into the conical flask should be perfectly colourless, because that's sodium sulfate solution, or in this case it will be what do we use, magnesium nitrate. So normally it would be sodium nitrate solution, and in this case it'll be magnesium nitrate solution with the chemicals that I've used. Now while that's going on, we can look at other such reactions. Now, leave that there going on. Move these out of the way. So to make the next one, look, silver bromide. Pick silver nitrate and sodium bromide. But I couldn't find sodium bromide, I got potassium bromide instead. You see, my cupboard over there doesn't have all the chemicals in it, only has some of them in it. So if I get this chemical, pour it, and mix it, potassium bromide, then the salt we're going to get will be silver bromide, which is a cream colour. Look, there, cream colour. That's a white colour. That's white. That's a barium sulfate. This is a silver bromide cream colour, and again, I could filter that. I could filter that in the same way that I am doing the filtering of barium sulfate. I'll top the barium sulfate up a bit, and I think probably I'm not going to bother with the rest. I'm just going to wait for that to go through. But the most spectacular of these demonstrations is this one. Look, lead iodide. Lead iodide. That one. Now, that chemical, lead nitrate, with that chemical, potassium iodide, the lead and the iodide will make a yellow precipitate called lead iodide. And the other ions, potassium with nitrate, will be left in the solution. And I can show you that here. So, lead iodide made by putting lead nitrate. There's lead nitrate with potassium iodide, look. And you form this lovely yellow, bright yellow, which if you keep watching it, and if I don't disturb it, the solid, this yellow solid, will settle down to the bottom of that beaker, and it will, that's the precipitate. And we could separate it if we filter. Now, can I show you this beaker here? This is the residue. Let me just take it out. That there is that filter paper that I've taken out of the filter funnel, barium sulfate. There. See? Barium sulfate is a white solid, and it's there, and you've made it. So let's get back to the PowerPoint. Barium sulfate, silver bromide, lead iodide. I did have another one, but I thought I was finding it hard to manipulate my phone and show you what was going on at the same time, and therefore I haven't shown you the fourth one. I do have it ready, but probably not worth showing it to you. Let's see if I can get you to understand the reactions. So you must understand the reactions. Here, we used barium nitrate, solution 1. Sodium sulfate, solution 2, makes our insoluble salt, barium sulfate, and it makes 2 lots of sodium nitrate. That's balanced. That is a full balanced equation for making that salt. Now, when I demonstrated it to you, I had magnesium sulfate, not sodium sulfate. But the same thing happens. Instead of sodium nitrate, you get magnesium nitrate, that's all. These ions, the ions that don't actually react, are called spectator ions. They're there before, they're there after. The sodium ions are there before, they're there after, and therefore they're spectator ions. I use magnesium sulfate. The magnesium ions are spectator ions. It doesn't matter what your spectator ions are. Obviously it matters if it didn't dissolve, but magnesium sulfate thankfully dissolves, and therefore it doesn't matter what they are. They are just left in the solution before and after. My second demonstration was silver nitrate with sodium bromide, that's the insoluble salt we're trying to make. Sodium nitrate. Here, lead nitrate. This was the yellow one. The yellow one was lead nitrate with potassium iodide. Again, potassium and sodium things dissolve, and therefore I had potassium iodide, not sodium iodide, but it doesn't matter, it's spectator ions. And it made lead iodide. That was the yellow. The lead iodide there is the yellow precipitate that we want as the salt, and the sodium nitrate. And the fourth one I had was making calcium carbonate here. Calcium carbonate, calcium carbonate. Can I go back? Barium sulfate. Oh. The barium ions are in one solution. The sulfate ions are in the second solution. To make barium sulfate, barium sulfate. To make silver bromide, silver in one solution, bromide in the second solution. To make lead iodide, lead in one solution, iodide in the second solution. To make calcium carbonate, calcium in one solution, carbonate in the second solution. Right, that is the idea. Now, you've done a number of equations, general equations, word equations, symbol equations, balance symbol equations. Well, now I need you to understand ionic equations. And believe it or not, ionic equations represent ions. And they make writing equations easier in these type of reactions. What we do is we write down the ions that are reacting, and we ignore the other ions, which are spectator ions, we ignore them. And doing that, then those equations that I've done there, those equations become much simpler, and they look like this. So barium sulfate making the salt. These ions, barium ions in solution 1 and sulfate ion in solution 2, that is, I've left off the 2 minus charge. There should be a 2 minus charge there on the sulfate, which I've left out. Sorry about that, but it's a mistake. Barium ions, sulfate ions, total charge before should be 0, total charge after is 0. That's why you need the 2 minus there. What about making silver bromide? Silver ions and bromide ions. What about making lead iodide? Lead ions and iodide ions. And the total charge is you need 2 iodide for every 1 lead. And balance these ionic equations in the same way that you do balancing of normal equations. Calcium carbonate, you make it with calcium ions and carbonate ions. And my pupils find ionic equations difficult. For the life of me, I can't work out why. Why would you find them difficult? Look, those are easier than those. Those, I would say to you, are harder than ionic equations. When precipitates form in these reactions, it's the ions that are coming together to make the salt. So, to show simply and clearly what's happening, we write ionic equations to represent these type of reactions. These equations only include the ions that are actually involved. They eliminate spectator ions. Let's write the previous equations. Those are ionic equations. Now, I'm going to take you through one ionic equation in much detail, and that is this one. Remember that yellow solid? Can you see there's some, where my finger is at the bottom, you can see the solid is settling, the solution above is clearing. Maybe if I turn it around you can see it a bit better. There you can see the solid at the bottom and the solution above is clearing. That I'm going to discuss now in more detail. So, word equation, lead nitrate solution, to make that lead iodide, sodium iodide solution makes lead iodide precipitate and sodium nitrate solution. I hope you understand that as a word equation, because they're the chemicals we mixed to make that beaker I've just shown you. And what would the balanced symbol equation look like? Well, there. Lead nitrate solution. Lead nitrate, AQ is solution. Sodium iodide solution. Sodium iodide, AQ is solution. Makes lead iodide precipitate. Lead iodide solid. And that is important. You put an S for solid. Sodium nitrate solution. Now what I need you to understand is that when you have lead nitrate solution, then the ions are separate. When you have the barium sulfate salt on your filter paper as a residue, the ions are together. They alternate in the solid. You got a three-dimensional positive, negative framework, a lattice of positive, negative ions that are together. They're not separate. So what we do is we talk about expand, and we can expand that. But the lead iodide we cannot expand. The lead iodide, because it's solid, the ions are together. And sodium nitrate, they're separate amongst the water. So these are separate ions amongst the water, separate ions amongst the water. These are separate ions amongst the water. Those lead iodide solid are ions together. They're not separate in the water. So when we expand it, it looks like this. AQ, 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 AQ. So 4 ions we're mixing together. And it makes lead iodide and 2 ions that are separate. And what we do is we eliminate spectator ions. Get rid of the ions that are on the left and on the right. So nitrate ions are there on the left and they're on the right. Get rid of those. Oh, can you not see that? Sorry. I was hoping you'd be able to see those. Nitrate ions, eliminate those. Sodium ions, eliminate those. What have you got left? Well, that leaves the ionic equation. The ionic equation, lead ions, iodide ions, making lead iodide. Now, I know that might seem difficult, but the logic is that we make chemistry easier. Make it easier for you to understand reactions because you're only writing down ions that are reacting. So, in that yellow solid, say you're trying to make lead chloride, just like that yellow solid was lead iodide. Lead chloride, say we made it in this method, what ions would you need? Well, clearly you need lead and chloride ions. Lead ions, chloride ions. You'd use lead nitrate solution. The nitrate would be the spectator ion. And you'd use sodium chloride solution. The sodium would be the spectator ion, but the nitrate, the sodium, we leave out because this is an ionic equation, and in ionic equations we don't put spectator ions in. Can you see how easy, if you know what you get, if you know what you're going to get, you just do an arrow and write the things that the ions you need to get it, and that gives you a quick way to do ionic equations. Now, the only way my pupils find this acceptable is if I give them lots of practice. So practice writing ionic equations, and then you'll see that they do in fact make chemistry easier for you and don't make it more and more difficult. So before I leave you, I just wanted to take you back to that. Beaker, where the precipitate, the yellow solid is there, and the top is clearing. Lead iodide as a spectacular yellow, and the solution above, if I leave it a few hours, that solution above will become perfectly colourless. All the yellow is down to the solid, and at the moment the top looks a bit yellow because the fine particles of solid are settling, and it will take time for it all to settle. Okay. So this lesson, salts by precipitation, is a method for making insoluble salts, salts that do not dissolve. And that's one of 3 methods. So I'm going to do 3 videos. This is the first one. Next time, I'm going to do what I call the general method. And the third time, I'm going to do titration. So there are 3 methods: precipitation, general method, and titration method for making salts. And you need to learn which you use when. At least this one is dead clear. If the salt does not dissolve, then this is how you do it. This is what you write about. You know the method. Pick 2 solutions, mix them together, get your salt that you want, filter it, wash it with a bit of water, and then dry it in a desiccator. Okay, I'll see you next time.